Hi everyone, welcome back to the channel. If you're getting started with Arduino, or if you have been working on projects and want to better understand the board you're using, then this video is for you. Today we're going to explore the digital pins of the Arduino Uno R3. What are they and how they work, and how each pin is used differently. By the end of this video, you'll know exactly what those pins labeled 0 to 13 actually do, and how to use them in your projects effectively. Let's start with the basics. On the Arduino Uno R3 board, there are 14 digital input-output pins. These are numbered from 0 to 13, and they can be used either to read digital signals from sensors or to send signals to actuators like LEDs or motors. A digital pin is very simple. It's either on or off, or in Arduino terms, high or low. When a pin is high, it's at 5 volts. When it's low, it's at 0 volts. You can set the mode of each pin using the pin mode function and either write a signal using digital write and read a signal using digital read. Some of these pins also support special features like PWM, interrupts, or serial communication, which we'll get into now, pin by pin. Let's now go through the digital pins one by one and understand what makes them unique. Pin 0 and pin 1 are used for serial communication. Pin 0 is the RX pin or receive pin, and pin 1 is the TX pin or transmit pin. These are connected to the USB port on the Arduino board via a serial chip, which allows your computer to communicate with the Arduino. If you are using serial monitor in the Arduino IDE to print messages or receive data, then pins 0 and 1 are involved in the process. It's important to know that if you are using the serial monitor, it's best not to use pins 0 and 1 for other functions in your project. They may interfere or cause unexpected behavior. Moving on to pins 2 and 3, these are general purpose digital pins, but they have an added capability. They can be used to trigger external interrupts. This means they can detect changes like a button press or motion from a sensor and immediately stop everything else the Arduino is doing to run a special function. This is incredibly useful in projects where timing is critical. For example, if you want to detect a sudden input while the Arduino is busy doing something else, an interrupt will make that possible. You can use attach interrupt in your code to assign interrupt behavior to these pins. On the Uno, pin 2 corresponds to interrupt 0 and pin 3 corresponds to interrupt 1. I found it very useful and interesting during my quadcopter project, where numerous signals pass through these pins from sensors and button presses. You can find the project on my channel, and anyways, I am planning to make a detailed video explaining the connections and program next month. Just watch out. Pins 4, 7, 8 and 12 are basic digital input-output pins. They don't have any special functions like interrupts or pulse width modulation, but they are incredibly useful in almost every project. You can connect buttons, sensors, LEDs, buzzers, and many other components to these pins. Just remember to set them as either input or output in your setup and using pin mode. Now let's talk about pins 3, 5, 6, 9, 10 and 11. If you look closely at the board, you'll see a tilde or wave symbol next to these pin numbers. That symbol means that the pin supports PWM or pulse width modulation. PWM is a technique used to simulate analog output using digital signals. This is especially useful when you want to dim an LED or control the speed of a DC motor. So even though these pins are digital, they can act like analog outputs when you use the analog write function. For example, if you write a value of 128 to a PWM pin using analog write 128, it will output a square wave where it's on 50% of the time. which averages out to about 2.5 volts. This is how we simulate analog controls with digital pins. Pin 13 is the one you'll probably use early on, especially when you're trying out the classic blink sketch. This pin is connected to an onboard LED. This LED is built into the board, so even if you don't use an external hardware connected, you can test your code and see something happen right away. Aside from the LED, pin 13 also serves another important role. It's used as the SCK or clock line for SPI communication. That's something to keep in mind if you're using SPI based modules like SD card reader or an SPI display. While we're on the topic, pins 10, 11 and 12 are also used for SPI. Pin 10 is the slave select or SS pin. Pin 11 is the MOSI, that is master out slave in, and pin 12 is the master in and slave out MISO pin. If you are connecting to devices that use the SPI protocol, these pins are the default ones the Arduino will use to communicate. If you are not using SPI in your project, you can also use these as regular digital input-output pins. As discussed in my previous video about analog pins, G and D is the ground pin. The ground pins are essential for the Arduino board to measure and set any voltage. Basically, a voltage is a difference of potential between 2 points. So here you take the ground and another point. So if everything in your circuit is connected to the same ground, all the voltages can be compared and their value is relevant. The next one is the AREF, that is analog reference pin on the Arduino Uno R3. It is used to provide a reference voltage for the analog to digital converter, ADC. When we are using analog read on analog pins A0 to A5, the Arduino converts the analog voltage 0 to a reference voltage into a digital value between 0 and 1023, that is a 10-bit ADC. By default, the reference voltage is 5 volts on most Arduino boards, including the Arduino Uno R3, meaning 0 analog input is converted to analog read and returns 0, and 5 volts analog input when read using analog read returns 1023. Sometimes though your sensor outputs a lower voltage range like 0 to 1.1 volt or 0 to 3.3 volt. If you keep the default 5 volt reference, the ADC resolution isn't great for such small signals. That's where AREF comes in. You can set a custom reference voltage by connecting your desired reference voltage to the AREF pin or by calling in your code. We use the function analog reference external to call the AREF in the code. Now the ADC will map 0 to the AREF voltage to 0 to 1023, improving precision. An important note is that if you use analog reference external, you should not exceed 5 volts on AREF or you risk damaging the board. If you are using a sensor that outputs 0 to 1.1 volt, set analog reference external, then connect a 1.1 volt stable voltage source to the AREF pin, and now the ADC maps 0 to 1.1 volts to 0 to 1023 instead of 0 to 5 volts to 0 to 1023, giving you a more accurate reading. The SCL and SDA pins are hidden behind the IC-SP1 connector. The SCL and SDA on the Arduino Uno R3 are used for I2C communication, a common protocol for connecting multiple digital devices like temperature sensors, OLED or LCD displays, real-time clock module and EEPROMs using only 2 wires. SDA, that is serial data line, transfers data between the master and slave devices. The other benefit is you can save GPIO pins by connecting multiple devices using just 2 wires, because each I2C device has its own unique address. The SCL, that is serial clock line, carries the clock signals generated by the master to sync communication. Again, as discussed in my previous video, SDA is also available on analog pin 4 and analog pin 5. They are also broken out as separate dedicated pins here. That's it about the pin structure of the Arduino. Knowing this pin structure will be very helpful in future videos where we'll be looking on practical projects. Till then, goodbye.